Hey viewers, how's it going? Here's another equipment autopsy. This is a homemade equipment autopsy that I built some years ago. What it is, it's a very quiet refrigeration chiller. And originally I built it for cooling the CPU on your computer so you could overclock it. So I'll just kind of show the outside of it, and then I'll take the top and sides off, show you inside it and how it all works, and eventually I'll hook it up to my CPU and show you what it's capable of. So this is the front. This is your condenser. You've got a 12 amp fuse, resettable fuse. You got your pump power. You got your main on-off power. Light indicator. Your compressor's on. You've got your refrigeration pressure, and you've got your temperature control. It's a fairly big box, but there's a reason for that. You can see it. It's just my hand. You can see just how big it is. I could have made it smaller, but this system has a redundancy built into it. So if the compressor stopped, your CPU wouldn't shoot up in temperature right away. So you got your inlet and outlet, and this is just where your air comes out of. I just made this design just with a jigsaw. Nothing on the other sides of it. It's on caster wheels, so moves easy. So next I'll open up the top and sides and show you all what's inside it. Alright, screws are out. I'll take the top off first. Alright, so what we got on top. So these are the inlet and outlet. So you see one. This is just a Coleman water cooler or ice box. So one goes in and it comes back out, and the other one runs along and it goes to a little giant water pump. I'm taking the screws out the sides. Just a little bracket there to hold this up. So there's your ice box. Here's where the work happens. So you've got your compressor. It's just a small Autopsy compressor. It's an AE140AT dash looks like 120. It's a 1/5 horsepower I'm just trying to read what I got written on top here. I actually wrote down what its watt capacity is. It's 6,500 BTUs. At minus 10 degrees Fahrenheit. So it's got pretty good capacity. I'll just get a flashlight here. It's a little bit dark. So you got your run capacitor for your compressor. You've got a run capacitor right down there for your fan. Your fan right back in there. A styrofoam fan shroud that I built around it. Increases the airflow and also because styrofoam is a sound dampener, it's actually makes this unit even quieter. Your condenser right there, and your switches, your electrical, your fuse. And it's been years since I heard this term. I think this is a CPEV valve, constant pressure expansion valve. It's not like a TX valve with a bulb that can open and close based on the loads. This here has a set screw on the back of it. You set it to the pressure you want and it will stay at that pressure no matter what the load is. Oh yeah, you got another capacitor there. That's a start capacitor. That's a run capacitor. So that's high UF. That's let's see. Looks like 200 to 280 microfarads, 125 volts. The run one, if I can rotate it here, 23.5 microfarads. Yeah, 23.5. Alright, I just got to plug it in, and I'll make it run with the sides off. Alright, she's powered up. So here we go. So now I'm not really going to run the pump very long because it's supposed to have water going through it, and that's why it's loud. It needs water to go through it to be silent. But as for the compressor, all I gotta do is turn this on here. It's hard to judge the noise level with the camera, but this thing's quiet even with the sides off it. And from the front, the fan noise just sounds like, say, like a 12-inch oscillating fan on, you know, number 2 setting or something. Maybe number 3. But even then, that's not very loud. So I've got the CPEV valve set to maintain a constant pressure of about 17 psi. Yeah. Now it won't actually take very long for this to cycle off. I've got this at the bare minimum setting and it won't take very long at all. Maybe within 5, maybe 10 minutes it'll cycle it off already. And when I said and the reason this, if the compressor stopped or something happened to the refrigeration side and it stopped cooling, there's a reason why your CPU wouldn't overheat right away, and that's a little idea I came up with. It's inside here. I'll have to take this tape off and open it up just to show you what exactly I've done. Okay, so a bit of a hiccup. I started to open this and I realized, or I should say I remembered, I can't open it without destroying it. So fortunately for me, whenever I do a project like this, I take pictures. And I always save my pictures. So the next best thing is just to show you guys what's in the ice box, just by showing you the pictures. So here's what we got. So this is a piece of 7/8 copper tubing and an end cap. Well, with end cap with a 3/8 hole in it. And that's looking down into the 7/8. That's with it welded shut. So you got 3/8 going in to 7/8, and it comes out. There's nothing inside that. That's completely hollow. And then you got 5 lengths of 1/4 inch that are brazed all into one piece. That's a piece of 7/8 as well. And there's an inside view of it. I got them aligned so they go along the outside of that long piece of 7/8. So kind of like that. Top view. And here's with them all brazed together for maximum heat transfer. And there's what you have in the box. So what is going on here? I think that's the last picture. Yeah, it is. So what's going on here is the 5 lines, the 5 1/4 inch lines are your refrigeration lines. So what it's doing is, so this line here is one of your refrigeration lines. I'm not sure which way it's flowing, but it doesn't matter. It's still can show you how it all works. So your liquid refrigerant comes down here, goes into your distributor here, and goes through your 5 1/4 inch lines, which are been brazed on the outside of that 7/8 piece. And it comes back up. It's kind of hidden by this picture, but you can see your return line, and that goes back to on the suction line of your compressor. The 3/8 line, which you see going down here and coming up right there, those are these 2 lines you're seeing here. So the refrigerant's cooling is cooling these 5 1/4 inch lines, and that cooling is transferring to the inside of the 7/8, which is where your fluid that's going to your CPU water block is traveling through. Now, the reason if your compressor stops that your CPU won't get hot in a hurry is because the whole thing, the whole container, is filled maybe about 5 inches up or so of an antifreeze mixture. So not only is the compressor cooling the fluid going through the 7/8, it's cooling the whole antifreeze mixture in here. So when the compressor gets it down to temperature, here's the last picture. That's your probe there for this. And that's just sensing the temperature of the antifreeze. So the refrigerant cools everything in here, and then the compressor actually shuts off. And as your CPU, the heat from your CPU gradually warms all this fluid back up, your compressor will come back on, cool it back down, and then shut off. So the compressor doesn't have to constantly run. And if the compressor failed, it would it would take in upwards of, say, half an hour for the CPU to warm up all this fluid in here. So it's got a lot of redundancy in it. It's got a lot of backup in it. And because I've actually got a water cooling loop on my CPU already, I can hook the system up with relative ease and just show you what temperatures it'll do. Now, my current setup isn't chilled. It's just a custom water loop that's air cooled. This is all it is right now. So you got your reservoir, here, a little water. It's the same. It's exactly the same pump as what's in the chiller. Little giant water pump. We've got a fan down there that doesn't spin very fast, doesn't need to, and our large coil off a dehumidifier. So those lines just run up into the side of my case to a custom-made water block. So it'll be easy to hook my lines onto this because it's the same size. It's 3/8 inch plastic tubing, and I'll be able to hook up the chiller and show you what temperatures it'll bring my CPU down to. Okay, so I've temporarily hooked it up to my computer just to kind of give you guys an idea of what it can do. And this is only temporary, so it's kind of messy. It's not how my computer normally is, but this is what I could do in a quick amount of time. So you got your pump. Your liquid gets pumped out there, goes up to this water block, homemade water block, and comes out, goes into your reservoir, and then the pump pulls it down inside in the container, super cooled, and then goes back out in a continuous loop. And I've got CPU hardware monitor open. So you're looking at this row here. These are current temperatures. That's what it's been down to since I put it on. And by stressing the CPU with CPU Z, so it's under stress right now. Now I keep my computer on just a air-cooled water loop, and when I stress it, the temperatures out when it's on just on the air-cooled, these go up to the 80s. So already that's a big difference. Just kind of stabilize at about, say, 54, 55 degrees. I turn that off, she drops right back down. Those temps will come down a little bit more since the system is still actually running. And that's the full amperage draw of the whole system, compressor, fan, and pump. So 3 amps. And to give you an idea of the noise level, I've got a realistic analog sound level meter. Now the way this thing works is you pick a number, and then so if the needle was on 0, that means that would be exactly 60 decibels. If it's at the 6 over here, that would be 54 decibels. If it's in the positive here, that'd be like, say it was on the 4, that'd be 64 decibels. So just going to give you a sound reading. As you can see, it's responding to my voice. And I say that's about, I don't know, about a foot away from the side there. So I will stop talking and I will show you guys what the noise level is. And then I'll put the piece of wood in front of it and you can see what it actually drops down to. So it levels off at about 63 decibels. So now I'll put the wood in front of it. And just watch the meter. Kind of hard to do with one hand, but here we go. Now I'm just kind of keeping it there. So that's down to 55 decibels. And I'll try putting the top on and see what that does. Now it's not perfect, but yeah, both the same. So it is pretty quiet. So I guess that's about it for this homemade liquid chiller. Subscribe, hit the like button, and stay tuned for more videos on some of my homemade stuff. Thanks for watching, everybody.